Good morning, students. Your physics teacher Hassan Darwish with you. This is video 3 about chapter 2, the linear momentum. In the previous two videos, I explained the concept of linear momentum of a particle and the linear momentum of a system of particles. Also, I proved the theorem of the linear momentum of a system of particles, in which P system equal Pg. I mean, the linear momentum of a system of particles equals the linear momentum of its center of mass, right? In this video, I'm going to explain the condition under which the linear momentum of a system is conserved and do some application. So let's start. First, I will explain the meaning of isolated system. What do you mean by isolated system? So by definition, the isolated system is a system which is not subjected to any external force, or the sum of the external forces acting on the system admits zero resultant. I mean, sum of forces equal 0. Okay? So now, conservation of linear momentum. Remember Newton's second law I explained in the first video in terms of momentum. Sum of forces external or the resultant force equals mAg, where Ag represents the acceleration of the center of mass. Now, I proved in video 1 this is the same as derivative of linear momentum with respect to time, right? So if the system is isolated, means what? Means zero resultant. It means this force, which is the resultant force or sum of forces, equal what? Equal 0. Okay? So what happened in this case? If sum of force is 0, then the derivative of the linear momentum of the system or its center of mass equals 0. Okay, you know from mathematics that if the derivative of a function is 0, then this function is constant, right? So the derivative of the linear momentum is 0, means that the linear momentum is constant. What does this mean? When the linear momentum is constant over time, means it has the same value like the mechanical energy. Okay? Hence, the linear momentum of a system is conserved. Let's write it in an equation form. Here it is. Linear momentum of the system initial equal linear momentum of the system final. The same as the conservation of mechanical energy. Okay? So let's do some application. First application, recoil of a cannon. Here is our cannon. Here it is, which consists of the gun, this is the gun, and the bomb. This is the bomb. Okay? Let's suppose that the masses of the gun and bomb are 100 kilogram and 5 kilogram respectively. The muzzle being horizontal, just for simplification, okay, to simplify the situation, ejects a bomb with an initial velocity 100 meters per second. Shows that the cannon must recoil with a velocity v vector, such that v vector is equal to m2, which is the mass of the bomb, v0 over m1, and then calculate v. Okay? Okay, here's our system. Okay? So system is what? Gun plus gun plus, sorry, plus bomb. Okay, this is our system. Now what are the external forces acting on this system? Here is our system. Let me use this color. This is our system, don't forget. Okay, now what are the external forces? We have the weight of the system acting at the center of gravity or center of mass, the whole weight of the system, and the normal reaction of the ground, of support, right? Sorry. Here it is. Only two forces, right? We neglected friction here. Now, what is the value of the sum of forces here? Sum of forces, external, which consists of the weight and the normal, equal how much? Equal 0, right? Okay, you may think that there is a force from the gun on the bomb. That's right. Also, there is a force from the bomb on the gun. That's right, due to action and reaction. But the two forces are not external, as you see. They are internal forces. So, and they are immaterial for us. We are only interested in the external forces. So the sum of the external forces 0, it means what? This system is isolated. So this system is isolated. What does this mean? It means what? Its linear momentum is conserved. Is that true? Linear, let me write it like this. Linear momentum is conserved. Okay, what does this mean? What does it mean? It means P system, as I said before, P system initially, or I mean before shooting the bomb is equal to P system after shooting the bomb, or final, right? Okay, good. But what is the value of the linear momentum of this system before shooting the bomb? Right? It's 0. Yes, you're right. Why? Because the system was at rest before shooting the bomb. Okay, good. Now, after shooting the bomb, our system is gun and what? Bomb. So we have two objects in the system. It means that the linear momentum of the system of particles, you remember, is P1 plus P2 plus, right? So here we have only two objects in the system. So it means this is the linear momentum of the gun plus the linear momentum of the bomb. Okay? Any problem? Good. So here 0 equal linear momentum according to the rule is, this is M1, I think, V, and this is M2, yes, with V0. And don't forget, this is a vector equation, not scalar. Don't forget the vectors. Clear? So it means that V equals, do some simple calculation, M2 V0 over M1. Okay? Look here. So we've proved V equal minus M2 V0 over M1. But what does the minus sign mean? So minus sign means that V is opposite to V0. Remember to this. So here, the minus sign means that V is opposite to V0. Okay? Which means what? The gun recoil. That is, the gun recoils. Okay? When you do this, even if you use a rifle and try to, for example, to fire from a rifle, you will feel the recoil of the gun. Is that true? Everybody sees this. So let's do the calculation. This simple calculation. Look at this equation. I want the magnitude of this equation, means the norm of this equation. So very easy to do it. So the norm or the magnitude of V, now because you want to replace numbers, you eliminate the minus sign, right? In the magnitude, M2 over M1 multiplied by the magnitude of V0. So let's replace the number, equal M2 how much? Here it is. M2, M1 100 and M2 5 and V0 100. So 5 times 100 over 100. So the gun will recoil with a speed just after ejecting the bomb or shooting the bomb. Okay, any problem? Easy calculation. Okay, in the next video, in video 4, I will continue the application on the conservation of linear momentum. So, you see here, conservation of linear momentum is as important as the conservation of energy. This is very important law in nature. Okay, see you on the next video. Take care. Bye-bye.